This is the lecture video for Quarter 2, Module 4. Our topic is still about the circular function. But in this video, we are going to solve situational problem involving the length of the arc, the area of the sector, as well as the simple harmonic motion. We had already discussed the topic about the arc length in the previous video lesson. But for the sake of discussing problems involving arc length, so we will be learning again the formula for the arc length. And this is, the arc length is equal to the product of the radius times the theta. And the theta should be in radian measure. In case the given angle is in degree, we need first to convert the degree into a radian measure so that we can use this formula. In the event that you are asked to find the value of the radius as well as the radian measure of the angle, try to familiarize this triangle. This is the formula for the arc length. Our S is the product of the radius times the theta. In the case of radius, you have to cover the radius, so that is S divided by theta. And in the case of the theta, cover the theta, so you have S divided by R. For our first problem, on a circle of radius 20 cm, the arc intercepts a central angle of 1/5 radian. What is the arc length? First, we will identify the given. The given are radius equals 20 cm and the theta, which is already in radian measure, is 1/5. And we are asked for the arc length. With the formula S equals R theta, substitute the value of R, which is 20 cm, and the theta 1/5. Multiplying 20 and 1/5, you have 4, and the unit is centimeter. Therefore, in this problem, the arc length is 4 cm. In this problem, find the radius of the circle if a central angle of 135 degrees intercepts an arc whose length is 2 cm. The given are the following. Theta is 135 degrees. The arc length, or the S, equals 2 cm. And we are asked to find the radius. We cannot go directly with the formula since our theta is not yet in radian measure. So we need first to convert 135 degrees to radian, is 3 pi over 4. To solve for our R, that is S divided by theta. R equals S over theta, substituting the values, and we will simplify this fraction. Remember that in getting the reciprocal of our radian measure, get only the reciprocal of the number. The pi will remain always in the numerator. So the 3 pi over 4, the reciprocal of that is 4 over 3 pi. So we have that 2 cm times 4 over 3 pi. Multiplying, that is 8 pi over 3 cm. And if we will use pi equals 3.14, the equivalent of 8 pi over 3 cm is 8.37 cm. Therefore, the radius of this problem is approximately 8.37 cm. Next problem, find the central angle that intercepts a 300 mm arc of a circle whose radius is 15 cm. The given are the following. Arc length, represented by S, equals 300 mm. The radius is 15 cm, and unknown for the central angle. Observe the units of our S and R. They have different units. Before proceeding to the solution, we make sure that the units used in our problems are consistent. We will be using centimeter instead of the millimeter. So we will convert first 300 millimeter to centimeter. Since 1 centimeter is 10 millimeter, therefore, this 300 millimeter is equivalent to 30 centimeter. And we will now get the formula for our theta, and that is S divided by R. Substituting the value, of S and R, we have 30 centimeter divided by 15 centimeter. So the answer for that is 2. The unit of our angle is in radian. We will now proceed to the problem involving area of a sector. A sector of a circle is the region bounded by an arc of the circle and the sides of the central angle. In that illustration, the shaded region is what we called as the sector. So we will be getting what would be the area of this sector given by a radius as well as the central angle. Take note of the formula of the area of the sector. That is 1/2 times the theta in radian measure times the r squared. We will now proceed to the problem involving the area of the sector. For the first problem, what is the area of the sector of a circle with radius 10 cm intercepted by a central angle of 45 degrees? So you have the formula area equals 1/2 theta r squared. Remember, the theta, the angle, should be in radian measure. And in this problem, since the given angle is in degree, convert that to radian measure and the equivalent radian is pi over 4. So you have that 1/2 times pi over 4 times the radius, which is 10 centimeter squared. Simplifying, so the result is 25 pi over 2 centimeters squared. That 39.25 centimeters squared is the value of the area of this sector with the central angle 45 degrees and the radius is 10 centimeter. This time, I will show to you how to make use of the formula of the area of the circle in getting the area of the sector. In the problem, we are given by radius equals 10 centimeter, and we will get now the area of the circle. The formula is pi r squared. Substituting the value of pi, which is 3.14, and r, which is 10, therefore, the area of the circle is 314 centimeters square. Consider the whole circle as 360 degrees, and we are only after the 45 degrees. To get the sector of the 45 degrees, since the whole circle is 360 degrees, we will divide the 314 centimeters squared by 360 degrees. And after that, you will multiply that to our sector of 45 degrees. So you have 314 divided by 360 times 45. Using your calculator, the answer is 39.25 centimeters squared. The area of the sector is just a portion of the area of the circle. For the second problem, find the area of the sector of the circle of radius 16 meters that subtends a central angle measured 3 pi over 4 rad. The solution in the module is already self-explanatory. So the area in this problem is 96 pi meters squared. To approximate this value, we will use pi equals 3.14. Therefore, the approximate value of 96 pi using pi equals 3.14 is 301.44 meters squared. We will now proceed to the simple harmonic motion problem. Kindly recall the sine and the cosine functions are periodic. So this simple harmonic motion accordingly is a periodic motion. They can be modeled by sine or cosine function. And the equations of this simple harmonic motion are given by this formula. The displacement y, directed height or length of an object behaving in a simple harmonic motion with respect to time t is given by the formula y equals a sine b t minus c plus d, or y equals a cos b times t minus c plus d. Every variable in this formula has its corresponding meaning. For our amplitude, which is the absolute value of a, that is from the axis to the highest point or from the axis to the lowest point. If you are given by the highest and the lowest point, the amplitude is half of the highest and the lowest point. For the period, The formula of the period is 2 pi over the absolute value of b. This period is the time required to complete one cycle. For the frequency, that is the number of cycles per unit of time, the formula is the absolute value of b over 2 pi. What would be this c and d? This variable c is responsible for the horizontal shift in time. If the given has a shifting of time horizontally, that would be the value of c. Variable d is responsible for the vertical shift in displacement. That is from lower to top or from top to lower. D is equal to the amplitude plus the lowest point. Before proceeding to the simple harmonic motion problem, let us first differentiate when can we use the sine and the cosine. Look at now the graph of the sine and the cosine function. If the function is sine, at the origin, value of the y is also 0. That is 0, 0. In the cosine function, at the origin, the value of our y is not 0 but somewhere above or below 0. So the difference is only this. In the sine function, the initial y is 0. And in the cosine function, the initial y is not 0. For problem number 1, in this problem, there is no horizontal shift in time and vertical shift in displacement. So, the formula later has no C and D respectively. Let us now try to figure out this problem. Suppose this is the weight suspended from a spring, and this spring is still in stationary motion, not yet moving. We pull down this load 5 cm below the resting position. So this will be the next diagram after pulling it below. And after pulling, it was released. So this load went into the air and the load reached its maximum height after 8 seconds. The question is, find the equation of the motion. Let us first identify whether this is a sine or a cosine function. Since our load was pulled down below before it was released into the air, therefore the y-coordinate of this diagram is not 0, but somewhere below 0. Therefore, the problem is a cosine function. And since we don't have the c and the d, so our equation is y equals a cos b times t. We will now identify the value of our a and b for us to get the equation of this motion. So we will now get the value of a, which is the amplitude. Amplitude is this one, from the axis to the lowest point, and the lowest point is -5, therefore a is -5. Next, we will get the value of b, and we can solve the value of b by using the formula of the period. And by definition, period is the time required to complete one cycle. Upon releasing this load, the time it takes to get the maximum height is 8 seconds. That is not yet the one cycle. So that is from up is 8 and going down that is also 8. This one, the traveling time from this weight until the maximum height is just half of the period. The entire period here is 16 seconds. Substituting the formula, period equals 2 pi over b. Therefore, the value of our b is pi over 8. So using this cosine function, a -5 and the b is pi over 8. So this is now the equation of this simple harmonic motion. This is the second problem involving simple harmonic motion. The important given in this problem are the following. The height of the signal varies from 1 feet to 9 feet above sea level. This will be the diagram of this problem. So the lowest point is 1 feet and the highest point is 9. And since this is periodic, the next highest point, which is 9 feet, can be reached after 3.5 seconds. We are asked now to get the constants A, B, and D. To solve for the amplitude, since we know that the minimum value is 1 and the maximum value is 9, so the amplitude is 1/2 of the difference of the maximum and the minimum. So that is 1/2 times 9 minus 1. The A is 4. To solve for B, we will utilize the formula of the period, which is 2 pi over B. And also, period is half of the maximum value. The highest point is 9, therefore, the period is half of 9, which is 9 over 2. We will equate this to 2 pi over B. Applying the cross multiplication, we have this result. Cross multiply 9 times B, so you have that 9B. 2 times 2 pi, so this one 2 times 2 pi. 9B equals, simplify, that is 4 pi. Dividing both sides by 9, therefore your B is equal to 4 pi over 9. To solve for our D, we have the formula D equals amplitude plus the minimum value. Amplitude here is 4 and the minimum value is 1. Therefore, the value of our D is 5. The given model of this problem is in the form h of t equals a sine b times t plus d. Substituting the values of a, b, and d, so the final model now becomes h of t equals 4 sine 4 pi over 9 t plus 5.